imagine feeding a massive, multi-billion parameter AI your absolute most sensitive proprietary code.
Right, or even asking it to analyze your private financial documents or something.
Yeah, exactly. And imagine that data never once leaves your desk. Like
Yeah.
zero cloud servers, no API fees, no Wi-Fi required at all.
Which sounds kind of impossible if you're used to the big cloud providers.
Right. But today, we are looking at how you can build exactly that. We are diving into Chapter 1 of this really fascinating source document titled The Data Engineer's Journey into Agentic AI. And our mission today is to completely demystify the process of building your very first local AI environment.
And this is huge for you as a listener, because if you've ever felt just completely bogged down by managing cloud API keys, or if you just want a concrete understanding of where the AI actually lives when it's running directly on your Mac, this deep dive is going to clear all of that up.
Totally. And it uses some brilliant analogies from the text.
Yeah, by the time we wrap up today, you won't just know a few terminal commands. You'll have a complete mental model of how AI hardware and software actually interact on your own desk.
Which is such a game changer. So the narrative in our source material centers on a student named Lavanya, and she's working with her mentor. And the whole thing basically kicks off with a massive roadblock.
A very relatable roadblock, honestly.
Oh, for sure. Lavanya is trying to build this application using GPT through a framework called LangChain, and she suddenly hits a rate limiter.
Yeah, the classic paywall.
Right, because she has completely run out of API credits. Her code is theoretically fine. She's in the absolute zone trying to learn, and suddenly the screen just goes black. Okay, let's unpack this. Hitting an API limit when you're in the learning zone is like putting your last quarter into an arcade machine just as you reach the boss fight, and the screen just goes completely black.
That is exactly how it feels. And what's fascinating here is how the mentor in the source treats this error. They don't see it as a failure or just, a prompt to go get a credit card. It's treated as a perfect opportunity.
Right, because usually tutorials just tell you to go to the billing dashboard and bump up your tier.
Exactly. But instead of pulling out a credit card for cloud billing, the mentor pivots entirely to building a local AI environment. They make Lavanya's learning completely independent of cloud APIs.
Which you should care about, because learning to run AI locally means unlimited, free experimentation. You get to lose the anxiety of that ticking meter in the background.
Yeah, when you are learning agentic AI, you need the freedom to break things 100 times an hour without it costing you $1 every time you hit enter.
Absolutely. So now that we know why we are going local, we need to understand what tools we are actually installing. The source lists a very specific tech stack.
Right, there's 3 main components they go through.
Yeah. First, there's Homebrew, which is the macOS package manager. The text describes it as an app store for developers. Then, they install something called Ollama. And finally, they download the model itself, which is Llama 3.2.
And that second step is where things usually get confusing for people.
Totally. I actually have a bit of pushback here, because this is a common point of confusion that Lavanya also had in the text. Wait, I thought Ollama was the AI model. Why do we need both Ollama and Llama 3.2?
It's a great question. And the mentor uses this brilliant analogy to explain it. You can think of a Llama as Netflix, like the platform itself, or even a DVD player. And Llama or Gemma or Quen, those are the movies.
Oh, wow. Okay, so without a movie to play, the DVD player is just sitting there doing nothing.
Exactly. Without a model to run, a Llama has absolutely nothing to execute. It's crucial to distinguish between the runtime environment, which is a Llama, and the learned parameters, which is the model itself, like Llama 3.2.
Right, so a Llama handles the low-level translation between the AI and my Mac's hardware, but it doesn't have a brain of its own.
Precisely. It's the infrastructure. The model is the brain.
Okay, so with the software stack understood, we transition to what literally happens inside your computer when you pull that model from the internet.
Yeah, the hardware reality of this is wild.
It really is. The mentor has Lavanya run this specific terminal command. It's a Llama pull, Llama 3.2.3b, and they force her to look at the exact terminal output.
Right, step by step.
Yeah. The logs show it pulling the manifest, which is the metadata, and then downloading 2 gigabytes of learned parameters.
Which is literally the distilled knowledge from millions of hours of training.
Yeah, compressed into 2 gigs.
Yeah.
But then, right after that, it verifies the SHA-256 digest to prevent corruption.
That part is super important. With an AI model, if even one bit is flipped or corrupted during download, the math breaks. It could just start hallucinating garbage.
Wait, really? Just from a tiny download error?
Oh yeah, it's not like a text file with a typo. It's a massive matrix of numbers. It has to be perfect. So the digest verifies it matches Meta's original file exactly.
Wow. Okay, then finally it writes the manifest to register it. Here's where it gets really interesting because thinking about where that file actually goes changed my whole perspective.
Oh, for sure. How so?
Well, if your computer's SSD is a massive library shelf where the AI book lives when the power is off, and your CPU or GPU is you like, the reader, then your RAM is the study table.
That is a fantastic way to visualize it, and it ties perfectly back to Lavagne's realization in the text. The model just lives on the persistent storage, the SSD shelf, when the Mac is off or idle.
Right, it's just inert data sitting there.
Exactly. When you actually run the model, Ollama acts like a librarian. It grabs the model from the SSD shelf and loads it onto the RAM, the study table, so the CPU reader can actually process it for inference.
So you're hauling 2 gigabytes of data from the shelf to the table just to answer a simple prompt.
Yeah, it's a massive amount of data movement.
Which makes me wonder about what happens when you want to invite another model to the party.
Right, juggling different models. The source talks about this.
Yeah, the discussion moves to switching from Llama to a different model like Google's Gemma. The source knows that switching models in code just means changing an identifier string, not rewriting the whole app.
It's beautifully simple on the software side.
But on the hardware side, if I start Gemma right after I was just using Llama, are both of these massive books sitting on my study table at the same time, doesn't my computer just run completely out of memory and crash?
That is the exact problem hardware resource management has to solve. It depends on your RAM, of course. But if memory is tight, Ollama is smart enough to unload the inactive model.
Oh, so it puts the Llama book back on the shelf to make room for Gemma.
Exactly. It clears the study table. But Lavanya actually notices this highly specific log detail about how long it waits to do that. She sees this setting called Ollama keep alive equals 5 millides.
5 minutes and 0 seconds.
Right. Ollama keeps an idle model warm in RAM for about 5 minutes. That way, if you ask a follow-up question, it's answered instantly because the book is still open on the table. But after 5 minutes of silence, it unloads it to free up space.
Ah, I love this because understanding this 5-minute timeout explains so much for you as a user. If your local AI feels blazing fast during a back-and-forth chat, but then takes a few seconds to wake up if you step away for a coffee, it's not broken.
No, not at all.
Your 5 minutes just expired. The librarian put the book away, and you have to wait for it to be hauled back off the shelf.
It's purely just memory management doing its job.
Mm.
And realizing that shifts how you think about the software, which actually pulls us back from the specific hardware mechanics to look at the broader software engineering philosophy highlighted at the end of the chapter.
Right. There's this great philosophical question Lavanya asks. If Meta created the Llama model, why does Ollama even exist as a middleman? Why wouldn't Meta just provide their own runtime environment?
It's a very valid question. You'd think they want total control over it.
So what does this all mean? It just seems wildly inefficient to have a middleman software in there.
Well, if we connect this to the bigger picture, it's all about the core lesson from the text standardization.
Okay, standardization.
Yeah. Imagine if every single model family, like Meta's Llama, Google's Gemma, Alibaba's Quinwhat, what if they all had their own proprietary installation process and a different API? The complexity for a developer would be completely overwhelming.
Oh man, it would be a nightmare. You'd have to rewrite your entire app just to test out a different model.
Exactly. Great frameworks reduce complexity by providing one consistent interface. Ollama abstracts all that friction away. You change one word in your code from Llama to Gemma, and Ollama handles the totally different underlying architectures.
That makes a ton of sense. It's like how web browsers standardize HTML so we don't need a different app for every single website.
That's a perfect comparison, and this underscores the mentor's final big lesson in the text. The goal of all this isn't to just memorize terminal commands. You can always look those up.
Right.
The real goal is to understand why these components exist and how they fit together. Once you get that, advanced future concepts like LangChain or RAG or LangGraph, they become so much easier to grasp.
Because you actually know what the machine is doing under the hood. Well, this has been an incredible journey today. We started with hitting that frustrating API paywall, to turning your Mac into a local AI host, and finally to understanding the exact dance between your SSD, RAM, and CPU using those library and study table mental models.
It really is an elegant system when you break it down like that. But, it leaves you with a final thought to mull over, building on that theme of local versus cloud AI.
Oh, what's that?
Well, If your incredibly powerful AI model lives entirely on your own SSD and never talks to the cloud, it raises an important question about the future of data. If all your interactions, your creative ideas, and your most sensitive code never leave your personal study table, does true digital privacy in the 21st century require us to just stop using the cloud entirely and go back to running everything locally?
Wow, that is a massive paradigm shift to think about. If the intelligence is local, the privacy is local. Well, thank you for joining this deep dive into the source material. We hope this gave you some serious food for thought. Keep asking why rather than just memorizing how, and we will catch you next time.